Good morning, my dear students. Under the topic environmental issues, I am discussing three aspects. One is pollution, which I was discussing in my earlier class, and then some more issues related to the environment I am going to take up in this class. And these are the agrochemicals. How far these agrochemicals have contributed to the pollution is going to be my discussion for a few minutes, and then we will go to other aspects of the pollution and the environmental issues. Now, coming to these agrochemicals, what is the meaning of the word agrochemicals? Agro stands for agriculture. The chemicals which are related to the practice of agriculture, it goes by a separate branch called agrochemicals. Just like a biochemicals, you have got agrochemicals. Now, the practice of using the chemicals for the purpose of agriculture, it came to India somewhere in the year 1950s, not before that. Before that, we didn't use any chemicals for the pesticide or insecticide or manure or anything of that sort. We were depending only on the biologically derived components for this. For example, we were using the green manure as the manure, and then for the pesticide and insecticides also we were using only the materials derived from the Azadirachta indica, neem and some more plants. So we were depending on only the biological materials even for agricultural purposes before 1950s. But what happened after 1950s? We started using chemicals for different things. As I was telling you, pesticides, insecticides, and then different type of herbicides, manures, different type of manures. Not only the NPK, nitrogen, phosphorus, and potassium. So all these things found their way into the agricultural products. What happened? The result was too much of usage in the agriculture, the chemicals. So what happened in this long span of nearly 65 years or so? It has these chemicals have considerably damaged our soil, considerably damaged. No more damage could be done. To that extent, it has been considerably damaged. All these chemicals over a long period has got an adverse effect, a bad effect, and then they have gone into the soil, completely, totally devastating the soil content. As a result of that, what was helping the agriculture once upon a time has become a pollution today. It has become a menace. It has become a nuisance for the human society. So these agrochemicals and their effects as a part of the pollution is what we are going to discuss now. In the wake of a green revolution, the use of inorganic fertilizers and pesticides has increased many-fold for enhancing the crop production. Pesticides, herbicides, fungicides are being increasingly used. These are very much toxic to non-target organisms. That's very important. See, you target a particular organism and then you apply a chemical. Particularly, for example, let us say a particular insect A is there which is causing a disease. So your idea is only to kill the A. Your idea is only to kill A. But when you are applying a chemical, it not only kills A, it kills at least 7 or 8 organisms along with A. 5 organisms. So these are called the non-targeted organisms. A is the targeted organism. So it kills the A along with other non-targeted organisms. But you remember, these non-targeted organisms are beneficial organisms. They are beneficial to the environment. So by using a chemical, you not only kill a target organism but also the useful organisms in the environment that are important components of a soil ecosystem. Now you understand how these agrochemicals have spoiled our health. See, first thing, it has it is a toxic. Number 2, it is killing the non-targeted organisms also. So the increase in the usage of the fertilizers, pesticides, fungicides, they are becoming a great problem to the farmers. So now we are shifting to the organic farming. This includes beekeeping, dairy management, water harvesting, composting, and agriculture in a chain process which supports each other and allow an extremely economical and sustainable venture. There is no need to use chemical fertilizers. No need to use chemical fertilizers for crops, as cattle excreta are used as a manure. Crop waste is used to create a compost which can be used as a natural fertilizer and can be used to generate natural gas for satisfying the energy needs of the farm. See, beautifully. So you select a area in your, say, a good garden. You have got a spacious garden, you select that. Now in this you have a place for beekeeping. Okay. Now when you are nurturing the bees there, so these bees are able to pollinate the crop or the flowers which are in the rest of the farm. So that's over. Then dairy management, you have a separate area for maintaining the cattle. You have grow some birds there. Okay, and then you have the crops in the rest of the place. You have a water source there in the same place. Now what happens? From this water source you can irrigate your farm. And this cattle you are maintaining here, this cattle, it will be giving their excreta that can be used as a farm manure, and these bees will be helpful to the what is known as the crops. And then some of the birds you are nurturing there, they will be also contributing the manure with the help of the excreta. See, crop waste is also used as a manure to create compost, which can be used as a natural fertilizer, not organic, chemical fertilizer, or can be used to generate natural gases by Gobar gas principle. You can generate electricity also. You can generate gas also for your day-to-day life activities. So within your farmland you can create your own, what is called as a food chain, and if possible a food web. You have few animals there, you have few insects there, and then few mammals there, and then some birds, reptiles, all these are just like a miniature forest. You can have your own components there, and then this becomes a beautiful ecosystem, and it is a self-satisfying ecosystem. This ecosystem is not depending on any chemicals. That type of ecosystem you can develop in your garden itself. Okay. So this in a large scale is what is called as an organic farming. Radioactive waste. This is the worst type of a pollution that the man is experiencing today. Initially, nuclear energy was hailed as one of the non-polluting way. Initially it was thought like that about 60 or 70 years back. But what happened later on? It was realized that the use of nuclear energy has two very serious inherent problems. Two very serious inherent problems. What is that? The first one is accident leakage. And the second one is the safe disposal of that. It's another biggest problem. Safe disposal of the waste, nuclear waste. Okay. So this has become, when compared to the other pollution, so this pollution is very detrimental, very dangerous, because you see the radioactive waste will be bring about the mutation in the organisms, and this mutation, in fact, you know very well that they are going to spoil the next generation itself. The babies will be born without hands, without legs, with all deformities, with all what is called as with inborn defects. Okay, so that type of effect the radioactive waste are going to produce on the human society. I'm just continuing the radioactive waste, how detrimental to the human. Radiation given off by nuclear waste is extremely damaging to the biological organisms because it causes mutations to occur at a very high rate. Already mutation is taking place in its own rate. Mutation is not always detrimental. You should not think it in that way. Mutations are always taking place, but you'll be increasing the rate of mutation, which is very detrimental. It's not going to contribute anymore to the evolution. That's going to result only in what is known as the birth of the children only with the deformities. Yeah, at high doses, nuclear radiation is lethal, but at lower doses it creates various disorders. The most frequent of all being cancer. Therefore, nuclear waste is an extremely potent pollutant and has to be dealt with the utmost caution. Now, one more concept in environmental issues. What is called as a greenhouse effect and a global warming. Now, these two things are always related. One goes with the other, a greenhouse effect and a global warming. So, what is a greenhouse effect? See, normally in a garden, in the botanical garden, or any college will have a greenhouse. Any college will be having a small area, what is called as a greenhouse. In this, we will be cultivating some of the plants which are living in colder climatic conditions. Okay, the arrangement will be like that. Now that will be completely closed with a glass on all sides, completely closed environment it is, because to produce the desirable climate there, we completely close it. Normally it will be closed by green glass. That may be one of the reasons why it's called as a greenhouse or glass house. They call it. It's a completely closed environment with a little ventilation. Now what happens? The heat is generated in that, and then that doesn't go out, and it will remain within the greenhouse. Okay. Now this so when there is a increase of a temperature within the greenhouse, it has been parked in the sun for a few hours. Therefore, the greenhouse warms up very much like inside the car that has been parked in the sun for a few hours. It is having a warm effect. The term greenhouse effect has been derived from a phenomenon that occurs in the greenhouse. It looks like a small glass house, and it is used for growing plants, especially during the winter. In the greenhouse, the glass panel lets the light in but doesn't allow the heat to escape. So the greenhouse warms up very much, like a car that has been parked in the sun for few hours. So this greenhouse is a leading factor for what is called as a global warming. The greenhouse effect is a naturally occurring phenomenon that is responsible for heating of Earth's surface and atmosphere. Without greenhouse effect, the average temperature at surface of Earth would have been chilly minus 18 degrees Celsius. See, without the Earth getting warmed up, without heated up, it will be minus 18 degrees Celsius. So very dangerous. Very dangerous. We can't normally, we Indians at least cannot live in that, because we are very comfortable with around about 20 to 25 degrees Celsius. And if it is going beyond 28 or 29, we feel a bit uncomfortable. And when it falls below 10 or 15 degrees, then also we feel comfortable. For us, for we Indians, we are very comfortable within that narrow range. The whole Earth will be minus 18 degrees Celsius when there is no, this heating process is not there. So this heating process is almost essential for the human life. But when it is going beyond a limit, then it becomes global warming. So in order to understand, so without a greenhouse effect, the average temperature of a surface of the Earth would have been minus 18 degrees Celsius rather than the present average of 15 degrees Celsius. In order to understand the greenhouse effect, it is necessary to know the fate of the energy of a sunlight that reaches the outermost atmosphere. So, in order to understand the greenhouse effect, what effect the greenhouse is having, it is necessary to know this fate of energy, how this energy is generated, how it is consumed, that which we are getting from sunlight. We have to go for the next slides. Now this greenhouse effect was discovered by Joseph Fourier in 1824. It's a process of absorption and emission of infrared radiation by atmospheric gases. Absorption and emission of infrared radiation by atmospheric gases. 4 points are involved here. Please note down very carefully. It is absorption of infrared rays and the emission of the infrared rays by what? By the atmospheric gases. The greenhouse effect is a process by which radioactive energy leaving a planetary surface is absorbed by some atmospheric gases called greenhouse gases. So, some greenhouse gases are there on the surface, on the atmospheric surface, and these are called the atmospheric gases, or otherwise it is called as the greenhouse gases. All the atmospheric gases are not greenhouse gases. See, some of the gases which are having the potentiality for absorbing and emitting, that alone are called as the greenhouse gases, and these greenhouse gases are remaining mixed with the other atmospheric gases. You have to understand it very clearly. This transfers energy to the surface and lower atmosphere, so the temperature there is higher than the normal. See, this is the infrared rays. This is solar spectrum, solar radiation. Now, what we are seeing, this is what is called a visible spectrum, and this visible spectrum, you know very well all these things you have studied in your physics, WebGR, okay. Violet, indigo, blue, green, yellow, orange and red, all these 7 colors. Now each one has got its own wavelength. We have expressed it in the form of the nanometer. starting from 380 nanometer ending with 750 nanometer is the visible spectrum. You call it as a visible spectrum. It is this light we can see by our eyes. It is this light when the wavelength is in this within this range we can see by. Now beyond on the left hand side it is ultraviolet, on the right hand side it is infrared. Infrared, ultraviolet, in between that you have got the what is known as the visible spectrum. There's a whole thing is a solar spectrum or solar radiation. It's the solar spectrum. Then you have got on this side ultraviolet side, you have got the still lower side X-rays, and then gamma rays, shorter wavelengths, and the longer wavelength side you have got after infrared, you have got the microwaves and then the radio waves. So in terms of nanometer, it goes from 10 point to the power of -5 to 10 to the power of 3 you have got. Okay, so this is a visible spectrum in the solar spectrum. This is a visible spectrum in the solar spectrum. Now in this what happens? What are the greenhouse gases which are present? See, chlorofluorocarbon, then HCFC, hydrochlorofluorocarbons, and halogens. These are contributing to nearly about 13.5%. Nitrous oxide alone 6.2%. See, methane, that contributes to 19.8%, and carbon dioxide to the maximum, that is a 60.1% of carbon dioxide. So these are the different gases present here, and these are the majority of the greenhouse gases. Carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, and then halogens. These are all the nitrogenous greenhouse gases. See how it is coming? These are all the greenhouse gases. The greenhouse gases are present in this layer, upper layer. Okay, greenhouse gases absorb long wavelength radiation, that is infrared radiation, from the earth and emit it again towards the earth. Okay, so it is absorbed and then this is returning back to the earth. The cycle continues till the earth's surface has no longer wave radiation to emit. So that is being sent back to the earth. Okay. This greenhouse effect and global warming, I was telling you, these two phenomena are linked together. Clouds and gases reflect about 1/4 of the incoming solar radiation. So clouds and gases reflect about 1/4 of the incoming solar radiation. So this is the earth, and earth is getting the radiation on all the sides. Out of this, 1/4 is being reflected and absorb some of it, but almost half of the incoming solar radiation falls on the earth's surface, hitting it, while a small proportion reflected back. Only a small portion is reflected back, whereas the remaining portion is absorbed by the gases. Earth's surface re-emits heat in the form of infrared radiation, but part of this doesn't escape into the space as atmospheric gases. Example, carbon dioxide, methane absorb a major fraction of it. Now you understand the problem. See, as this heat is not escaping into the space, it is not escaping into the space. Why? This carbon dioxide, methane, carbon monoxide, all these gases, they absorb it and they don't allow it for escape, and that becomes one of the important reason for the global warming. The molecules of these gases radiate heat energy, and a major part of which again comes to the earth's surface, thus heating it up once again. This cycle is repeated many a times. The above mentioned gases, carbon dioxide and methane, are commonly, they are called as greenhouse gases because they are responsible for the greenhouse effect. They are responsible for the greenhouse effect. Increase in the level of the greenhouse gases has led to considerable heating of Earth, leading to global warming. During the past century, the temperature of Earth has increased by 0.6 degrees Celsius. Most of it during the last 3 decades. See, during the past century, 100 years, in the last 100 years, during the past century, the temperature of the Earth has increased by 0.6. See, you may say, oh, it's only 0.6 there. What is this? It's not even 1. It's only 0.6 degrees. See, you must understand the average temperature of the whole Earth increasing by 0.6 degrees Celsius is not a joke. If it is going to increase by 2 or 3 degrees, a lot of changes are going to happen in this Earth. See, the polar ice will melt, and then El Nino effect will come. So many, even within 2 or 3 degrees Celsius, a lot of a change will take place in the Earth. Okay. So 0.6 degrees Celsius, you may think that it is not a great value, but in nearly 100 years, it has increased 0.6 degree, and that too, that majority of that during the last 3 decades. Now we understand how our modern life has contributed to the greenhouse effect, our modern style of life. This has mainly contributed to the global warming. The Earth's average temperature has risen by 0.6 degrees Celsius. That has happened mainly during the last 3 decades, the last 30 years. See, out of this 100 years, only major changes have taken place only in the last 30 years. Scientists believe that this rise in temperature is leading to deleterious changes in the environment and resulting in odd climate changes. Example, El Nino effect, leading to increased melting of polar ice caps, as well as of other places like the Himalayan snow caps. So there is going to be the melting of ice, there's El Nino effect, and there is going to be a deleterious effect on the environment because of the increase in the temperature of the average temperature of the globe, the Earth. Another very important problem is the ocean sea level rise. Okay, see, it will all come only to a very little thing, but even this little change is going to tell a lot upon the human life. 0.44 millimeter rise. See, 0.44 millimeter rise. Not even 1 millimeter rise. See, 0.5. 0.44 means 0.5. 0.5 millimeter rise year before 1900. Before 1900, it was only 0.5, and it was 1.5, more than 1.5 after the 1900. Then it is 3 millimeter rise after 2000. 3 millimeter rise of ocean level. This 3 millimeter means something great. See, you have to compare. See, this is the ocean level, this is the sea level, and very nearer to the sea level you have got the land, and on this land only human being, we are all living. If there is going to be an increase, the sea water will flow into the land. It may be by few millimeters, but still what effect it is going to have, that's very important. See, 3 millimeter rise year after 2000, 120 meter rise in the last 10,000 years. See, for further rise, low-lying islands are lost. See, low-lying islands are lost. Some of the islands are getting buried in the sea. 16% of the coral reef already lost. 16% of the coral reef already lost. 3.5 degrees Celsius will be there, and 40% of the lives will be lost. See, this is what I was mentioning. It may look, what is there, sir? If 1 degree is increasing, what's going to matter for us? See, 3.5 degrees Celsius rise in the temperature will kill nearly 40% of the life in the world. So if there is going to be 5 or 6 degree rise in the average temperature of the earth, then the whole life will come to an end. The whole life will come to an end. See, nobody can live in this world after that. And the average global heat is going to rise to this level, but it's not going to happen within next few years. That's a different matter. So this is more than sufficient to kill 40% of the lives. We have to understand the gravity of the problem as it stands today. Seasons will change. Long summer will come. Winters will become shorter. More cyclones and harsh winds will be there. Rain will become very less, and 20% of more rain will be there in unrainy season. Floods and droughts will be alternating. So these are all something against the nature. This was happening about, it's a part and parcel of our Earth's changing atmosphere. But these things happen once in 100 years. Once in 100 years. Very rarely you will get a flood. Very rarely you will be getting droughts. But that's going to be a regular feature hereafter. That's what I am telling. It's going to be a regular unseasonal rain, I was telling you. Human and crop loss will be there. Rise in the sea level, sea water intrusion will be there. So these are all some of the impacts. Some of the impacts of a global warming. See, a beautiful slide. How the whole forest is set on fire. Raging forest fire. See, this forest fire, what effect it's going to have? God knows. See, all the cattle are killed. The animals which cannot fly for a longer distance, they are also killed. So many soil microorganisms, billions and billions and billions of microorganisms will be killed in the soil, and that soil will become not usable in the near future. So when a particular place is burnt and it is reduced to a handful of ash, what will happen? You can just imagine the effect of the global warming. El Nino effect. Interaction of unusually warm or cold sea surface temperature in the eastern and central Pacific Ocean is what is called as El Nino effect. Unusually warm, unusually cold. Where? In the sea surface. Where? Once again in the eastern and central Pacific Ocean. If that is taken, it is what is known as El Nino effect. It causes erratic weather patterns in all parts of the world. So even though it occurs in the eastern and central Pacific, it is affecting the whole world, all parts of the world. Once a rare cyclic weather condition has become more frequent, persistent and intense in recent decades. So what was a very rare one once upon a time has become frequent, has become persistent, has become intense in the recent decades. So what all I am telling, so all these changes are happening in the environment, in the earth. For the past 100 years, 1000 years it is happening. But the problem is in the recent future, in the recent past, in the last 100 years, last 50 years, and it has become aggravated, it has become more. That's our argument. So who is responsible for this? The global warming. And global warming, in fact, is due to the contribution that we have made to the earth. Ozone depletion is another very big problem in the stratosphere. Ozone is found in the upper part of the atmosphere called stratosphere, and it acts as a shield absorbing ultraviolet radiation from the sun. So ozone O3, it is a very beautiful shield. It's a beautiful shield absorbing the ultraviolet radiation from the sun. So the sun's rays are containing ultraviolet rays also. These ultraviolet rays are dangerous for the human health. So it has to be filtered, it has to be removed from the sun's solar energy or the solar radiation. So this ozone is becoming a shield. It is forming a shield to protect the human and the other organisms from that. UV rays are highly injurious to living organisms, since DNA and proteins of living organisms preferentially absorb UV rays, and its high energy breaks the chemical bonds within these molecules. So preferentially the ozone layer absorbs UV rays. So it has got a beautiful capacity. The ozone has got a beautiful capacity. It has got a preferential over the UV rays, and these UV rays are being filtered by the ozone layer, and this layer is very comfortable for us, because the living organisms cannot expose themselves to the complete solar radiation, and it can expose itself only after filtering the UV rays, since the DNA and the proteins are much damaged by the UV rays. Ozone depletion in the stratosphere. The thickness of the ozone in the column of air from the ground to the top of the atmosphere is measured in terms of DU, Dobson unit. Like any other unit, this is also named after the scientist who found out, Dobson unit. Ozone gas is continuously formed by the action of UV rays on molecular oxygen, and also degraded into molecular oxygen in the stratosphere. There should be a balance between the production and degradation of ozone in the stratosphere. Beautiful. So there should be a balance between the production and degradation. To what amount it is produced, to that amount it is degraded, then it will be maintained constantly. Okay. Of late, the balance has been disrupted due to the enhancement of ozone degradation by the chlorofluorocarbons, popularly called as CFCs. What is this CFC? So they are produced only by the refrigerator and different type of bulbs that we are using today. Okay, we are going to the detailed account of that. The CFCs discharged in the lower part of the atmosphere move upward and reach the stratosphere. It goes to the stratosphere. In stratosphere, UV rays act on them, releasing the chlorine atoms. Chlorine degrades ozone, releasing molecular oxygen, with these atoms acting merely as a catalyst. Chlorine atoms are not consumed in the reaction. See, that's the problem. Chlorine atoms are not consumed in this reaction. Hence, whatever CFC, chlorofluorocarbons, are added to the stratosphere, they become permanent and continuing effects on ozone levels. Although ozone depletion is occurring widely in the stratosphere, the depletion is particularly marked over the Antarctic region. That's a very important point. So, ozone depletion is generally taking place. It is resulting in the thinning of the stratosphere. So, it is there. If this is the ozone layer, it is getting thinning. Here and there, the ozone layer is getting thin. But in a particular Antarctic area, it is very much as a result of the hole is formed, a complete hole is formed. This has resulted in the formation of a large area of a thinned ozone layer, commonly called as a ozone hole. Ozone depletion in the stratosphere, UV radiation of a wavelength shorter than ultraviolet B are almost completely absorbed by Earth's atmosphere, given that the ozone layer is intact. But UVB damages DNA and mutation may occur. It causes aging of skin. First problem. Damage to the skin, because the skin is mostly exposed to the radiation. In human eye, cornea absorbs UV radiation, and a high dose of UVB causes inflammation of cornea called snow blindness, cataract, etc. Such exposure may permanently damage the cornea. See, first problem about the ozone layer depletion, and the first thing, the main thing affected is the eye and the skin. Okay. Eye and skin. These two are much affected by this problem. Others not that much. You know, cancer is another effect. Perhaps it refers to the skin cancer. See, the ozone layer, stratosphere, and it is the solar energy is coming, and part of that is being absorbed, and that which is the unused chlorine, that is stagnantly staying there, forming what is known as the chlorofluorocarbon, and that is becoming responsible for the ozone depletion. Once again, the ultraviolet rays, UVC, UVB and UVA, UVB is more responsible for that in the altitude of 50 kilometers. So this is the outer space, mesospace, and then the stratosphere. This is the stratosphere, and it is in this stratosphere you have got the ozone layer. Okay, this is the ground surface where we are living. Perhaps the last slide. Ozone depletion in the stratosphere. An international treaty known as the Montreal Protocol was signed at Montreal, which is in Canada, in 1987 to control the emission of ozone depleting substances. Subsequently, many more efforts have been made, and the protocols have laid down definite roadmaps separately for the developed and developing countries. You cannot have a same rule for two things. See, you divide the different countries into poor countries, well-off countries, developing countries, developed countries, etc. So, India is classified under the developing countries. It was a poor country once upon a time. Now only we have become a developing country. Other countries like Canada, USA and others, some more countries are there. They are all developed countries. So, you can't have a same rule, you mean only one yardstick for measure all the things. So, they have laid down different protocols for the different countries to minimize the ozone depletion in the stratosphere, and that was done in the 1987 protocol, Montreal Protocol. Okay. So things like this is going on. When we realize that certain things are deleterious to the human population, we understand and then we take steps. Government also taking steps at its own level. So in our today's class, we have seen what are the problems to the environment because of the greenhouse, ozone depletion, and agrochemicals, etc. So in some way or other, we are fighting with these things to minimize the adverse effect of these things. A little more of that of this nature as a part of the environment issues or environmental problems, I will be covering in my next lecture also. Thank you very much for listening to me for all these lectures that I am discussing about the environment. And if I got any doubt, I will be very happy to clarify all your doubts. Thank you, my dear children.